In Part 1 of the Unit 10 notes, we will be covering gas pressure, atmospheric pressure, factors affecting pressure, units of pressure, and pressure conversions. If you are following along in the online textbook, this is section 11.1 through 11.18. Gas pressure results from the collision of gas particles within an object. While each individual gas molecule is only capable of exerting a minuscule amount of pressure, the billions of gas molecules which can fit inside a container have the potential to exert a large amount of pressure. Inside a balloon, the gas particles collide with the balloon's inner walls. It is those collisions which keep the balloon inflated. If the gas particles were to stop moving, the balloons would instantly deflate. So the amount of pressure inside of a sealed container is directly related to the speed of the molecules, since that is connected to the amount of force that they are exerting on the walls. Atmospheric pressure. The barometer is an instrument used to measure atmospheric pressure. It was invented by the Italian physicist Evangelista Torricelli in 1643. A traditional mercury barometer consists of an evacuated tube immersed in a container of mercury. Air molecules push down on the surface of the mercury, which causes it to rise inside the tube. The height to which the mercury rises is dependent on the external pressure. So over here we can see in this diagram that we have the atmospheric pressure, which is applying a force on the tub of mercury. The mercury is then forced up the tube to a specific level, which is then measured. And here we can see millimeters of mercury. That is actually one of our original units for pressure. Here are some factors which will affect your pressure. First, our amount of gas. Increasing the number of particles will increase the number of collisions, which will increase the pressure. Removing particles will reduce pressure. So the more gas you have within a sealed container, the more pressure there will be. Volume. By increasing the volume, you will decrease the pressure of the gas since collisions are less likely. Decreasing the volume is going to have the opposite effect. Temperature. Increasing temperature will increase the speed of the molecules, which leads to more collisions and greater pressure. Decreasing the temperature will have the opposite effect. Here are the units of pressure that we are going to be using within our gas laws unit. First is ATM, which stands for atmospheres. We also have kPa, which is kilopascals, torr, which is torr, mmHg, that's millimeters of mercury, and psi, which is pounds per square inch. Now throughout the unit, you may be asked to convert from one to the other. To do so, you can use the conversion factor, which I have here. So 1 atmosphere is equal to each of the following units. So I can convert between atmosphere and torr, or millimeters of mercury and kPa, or any direction that I might need to. So to demonstrate that, we are going to be going through a couple of pressure conversions. The atmospheric pressure in a mountainous location is measured to be 613 millimeters of mercury. What is the pressure in ATM? And what is the pressure in kPa? So we're going to write down what we're starting with, which is 613 millimeters of mercury. And since we're starting with this unit, that unit is going to go on the bottom. Whatever unit we're looking for is going to go on the top. These are all going to be one-step conversions because all of these units can be related to each other directly. I'm asked for atmospheres first, so I'm going to put that up top. We get our numbers from this conversion factor. So 1 atmosphere is equal to 760 millimeters of mercury. So I have 1 over 760. From here, we just need to divide and then round for the proper number of significant figures. We have 3 significant figures here with the 613. So that's going to come to 0.807 atmospheres. Now in this problem, we are also asked for this pressure in kPa. I could convert from the atmospheres into kPa, but I could also convert from the original millimeters of mercury, and that's what I'm going to do. So I'm going to write down my 613 millimeters of mercury again. Millimeters of mercury is still on the bottom, but this time I'm going to be going to kPa. Millimeters of mercury is still going to be 760, but this time I have to use a different number for the kPa. So that's going to be 101.325. I'm going to multiply by the top and then divide by the bottom. And I'm going to round for 3 significant figures again because of my starting value. So this comes out to 81.7 kPa. In our second checkpoint question, we are asked to find the pressure of a volleyball. It is currently 4.29 psi, and we want to know what that pressure is going to be in torr. So just like in the previous problem, I'm going to write down the value that they start us with the unit. Now I'm going to set up a one-step conversion. Since I started with psi, that has to go on the bottom. I'm looking for torr, so that's going to go on top. PSI is 14.7 according to my conversion factor, and torr is 760. So I'm going to multiply by 760 and then divide by 14.7. This is going to come out to 221.7, but I need to round that to 3 significant figures. So that's going to be 222 torr. That concludes part 1 of our Unit 10 notes. When we come back for part 2, we are going to be covering Boyle's Law and Charles' Law.